Hello students, the next topic in computer organization, the first module we are discussing about this, that is bus structure. As I told you earlier, a bus is a group of lines that serves as a connecting path for several devices. So it's a carrier, right, which is used to transfer the data from one location to other location. A bus is a group of lines. That's what explained here, mentioned here. But the bus must have lines for data transfer, address transfer, as well as the control. So there are basically bus is nothing but a set of three wires: data, address, as well as control. Transferring of data, transferring of the location value, as well as transferring of the control information. So because the bus can be used for only one transfer at a time, only two units can actively use the bus at any given interval. Bus control lines are used to arbitrate multiple requests for use of the bus. So at a time only one person can use it. Please remember, at a time only one person can use it to avoid the confusion, because so many data will be there, right? At a time one can speak, or maximum two members can, right? One-to-one communication, even though it is a crowd, but if everybody starts speaking, what will happen? It will create a noise, right? To avoid that noise, we are following certain rules. In the same way, how we follow the rules in real world scenario, in the same way it will be in with respect to our computer science as well. At a time only one unit is allowed to use the bus to avoid the confusion, or to avoid the noise. So this is what the structure of the single bus. As you can see, all the IO devices are connected to memory and processor. All the four units, input device, output device, memory, as well as processor, are marked as a block, separate block, or they are all connected through a common channel, through a common arrow mark. What is that? Single bus it is called as. You can see all the arrow mark carefully. Input device will give the data to computer, isn't it? That's why check the arrow mark. Data is captured from input device and sent on to the bus. Data is sent on to the bus. Say outward arrow, there is no inward arrow for input device, right? But output device, there is no outward arrow, only the inward arrow, because monitor normally, forget about touch screen, monitor or printer which doesn't take the input, it just provides the output. Okay, don't consider the touch screen concept, where touch screen can take the input as well. That is different. So normal monitor, or say printer, it cannot take the input. What it does, it simply sends the output, right? That's why it takes the data from the processor, send, so outward, so inward arrow for an output device, from there data will be sent or displayed. Memory, there is a bidirectional arrow for memory as well as processor. Very easy to understand. Memory can take the input as well as it can send the output. Whenever you are creating the data, whenever you are creating a new file, you are going to store it. You are, as soon as you try to store, what will happen? You are sending the data to the memory, right? There should be an inward arrow for memory. Whenever you are accessing the data from the file, from the memory, whenever you are accessing either the same file or any stored file, the data should be taken from memory and brought onto the bus. So outward arrow is must. That's why you can see the bidirectional arrow for memory. Concentrate carefully on the picture. Similarly, for the processor as well, processor can take the data as well as it can send the data. Whenever it wants to process, it will take the data from input device or even from memory. So there is an inward arrow. And once the data is processed, what it does? It sends the data onto the computer, onto the monitor, using same bus. So there is an outward arrow. right? This is what the single bus structure, very simple concept. That's it for this session. Let's continue our discussion later in the next session. Thanks for watching.